Hello students, welcome to ePhysics. Students, in this video we will be discussing about relative permittivity. Now students, relative permittivity is also known as dielectric constant. Okay, it is also known as dielectric constant. Clear? Now students, we know that from the Coulomb's law that if we write it like this, we know that now from Coulomb's law, force between 2 point charges, let us consider first in a vacuum. Okay, we will denote it with FV, which is equals to 1 by 4 pi epsilon naught Q1 Q2 upon R square. This is the case when the 2 point charges Q1 and Q2 separated by a distance R is kept in vacuum. Now students, if we keep these two charges in any medium, that is the force between any two charges Q1 and Q2 kept at in any medium at a distance R. In that case students, what we see that force in the medium that we will be denoting with F small m will be equal to 1 by 4 pi epsilon. Here we have taken it as epsilon naught, here we will take it as epsilon only. Q1 upon Q2 upon R square. Let us consider this is equation 2. Here the epsilon is, sorry, I have written it as epsilon naught. It should be epsilon only. Here epsilon means the relative permittivity, sorry, the absolute permittivity of in the vacuum. Here epsilon means the absolute permittivity of medium. Okay, now epsilon is absolute permittivity of medium. Clear? Now students, if we divide equation 1 from equation 2, that is this equation divided by this equation, that is FV upon FM, what do we get? Okay, divide equation 1 from equation 2, what do we get over here? That force between two charges in vacuum divided by force between two charges in any medium will be equal to, okay, it will be epsilon upon epsilon naught. Now this ratio of absolute permittivity of medium by or to absolute permittivity of vacuum is known as relative permittivity, epsilon R. We also denote it as K in some instances. Let us consider this is equation 3. Now students, from equation 3 we can see clearly, from equation 3 we can see clearly that epsilon is equal to epsilon naught into epsilon R. Now if we substitute this value in equation 2, okay, in equation 2 what do we get over here? That force in any medium is equal to 1 by 4 pi epsilon was written over there. In the place of epsilon we will substitute it with epsilon naught into epsilon R. Clear? Will be multiplied by Q1 Q2 upon R square. So this is the equation, okay, of relative permittivity, that is absolute permittivity in vacuum and absolute permittivity in medium. So we have considered it. Also students, in some books you might see that Fm is equals to 1 by 4 pi epsilon naught. In the place of epsilon r, it is dielectric constant K, okay, multiplied by Q1 Q2 upon r square. So both the equations are correct. In different places different thing is written, different symbols are used, but both the things are similar. Okay, so here epsilon r is nothing other than the relative permittivity, which is also known as dielectric constant. So it is nothing other than relative permittivity, or simply we can say it as dielectric constant, which is also denoted as K. So this is it with the video. I hope you understood it clearly. Thank you very much for watching.